we know that new plate material is being formed, and these lithospheric plates on the surface of the Earth are moving around. And that might raise the question in your brain, what happens if we kind of reverse things? We know the direction they're moving in. What does that tell us about where they came from? So let's just do the thought experiment. Right now, South America and Africa are moving away from each other because of new plate material being created at the mid-Atlantic rift. Let's rewind it. Let's bring them back together. Let's bring them back together. We know that India is jamming into the Eurasian plate right now, causing the Himalayas to get higher and higher. What if we rewind that? Let's bring India back down towards Antarctica. Same thing with Australia. We have new plate material being formed between Australia and Antarctica that's making the continents move apart. Let's bring them back together. Let's rewind the clock. Even North America. It's not as obvious from this diagram, but if you actually look at the GPS data, it becomes pretty obvious that North America right now is kind of moving in a counterclockwise rotation. So let's rewind it. Let's go back, moving it in a clockwise direction. Instead of Eurasia going further away from North America, let's bring it back together. And so what you can imagine is a reality where India, Australia are jammed down into into Antarctica. South America and Africa are jammed together. North America is jammed in there, and essentially Eurasia is also jammed in. So it looks like they're all kind of would clump together if you go back a few 100 million years. And based on just that thought experiment, you could imagine at one point all of the continents on the world were kind of merged into one supercontinent. And that supercontinent is called Pangaea. Pangaea. Pan for entire or whole, and Gaea for coming from Gaia for the world. And it turns out that all of the evidence we've seen actually does make us believe that there was a supercontinent called, well, we call it Pangaea now. Obviously, there probably weren't things on the planet calling it anything back then. Or there were things back then, but not things that would actually go and try to label continents that we know of. But all of the evidence tells us that Pangaea existed about 200 to 300 million years ago, roughly maybe 250 million, give or take, years ago. And I want to be clear, this was not the first. This was not the first supercontinent. To a large degree, it's kind of the most recent supercontinent and it's easiest for us to construct because it was the most recent one. But we believe that there were other supercontinents before this. That if you rewind even more, that you would have to kind of break up Pangaea and it would reform. But now going back in time, or that there were several supercontinents in the past that broke up, reformed, and the last time that we had a supercontinent was Pangaea, about 250 million years ago, and now it's broken up into our current day geography. Now, I won't go into all of the detail why we believe that there was a Pangaea about 250 million years ago, or this diagram tells us about 225 million years ago, give or take. But I'll go into some of the interesting evidence. On a very high level, you have a lot of rock commonalities between things that would have had to combine during Pangaea. And probably the most interesting thing is the fossil evidence. There's a whole bunch of fossils, and here are examples of it, from species that were around between 200 and 300 million years ago. And their fossils are found in very specific place. This animal right here, Cynognathus. I hope I'm pronouncing that right. Cynognathus. This animal's fossils are only found in this area of South America, a nice clean band here, and this part of Africa. So not only does South America look like it fits very nicely kind of into Africa, but the fossil evidence also makes it look like there was a nice clean band where this animal lived and where we find the fossils. So it really makes it seem like these were connected, at least when this animal lived, maybe on the order of 250 million years ago. This species right over here, its fossils are found in this area. Let me do it in a color that has more contrast. In this area right over here. This plant, its fossils. Now this tries to connect a lot of dots between a lot of content. Its fossils are found in this entire area. Across South America, Africa, Antarctica, India, and Australia. And so not only not only does it look like the continents kind of fit together in a puzzle piece, not only do we get it to a configuration like this if we essentially just rewind to the movement that we're seeing now, but the fossil evidence also kind of confirms that they fit together in this way. This animal right here, we find fossils on this nice stripe that goes from Africa through India all the way to Antarctica. Now this only gives us evidence of kind of the southern hemisphere of Pangaea. But there is other evidence. We find kind of continuing mountain chains between North America and Europe. We find a rock evidence where, just the way we see the fossils kind of line up nicely, we see common rock that lines up nicely between South America and Africa and other continents that were at once connected. So all of the evidence, as far as we can tell now, does make us think that there at one time was a Pangaea. And for all we know, all the continents are going to keep moving, and maybe in a few 100 million years we'll have another supercontinent. Who knows?